Alright, starting with UCS Manager version 1.4, a new port type was introduced called an appliance port. Now we've had uplink ports and server ports up to this point, so an appliance port was added to the portfolio. And the motivation behind the appliance port was to make it easier to attach third-party appliances, such as a NAS filer, directly to the Fabric Interconnect. Now before version 1.4, if you tried to do this in end host mode or switch mode, there were some problems with that. So for example, in end host mode, if you were to take the NAS appliance and attach that to an uplink port, that simply would not work at all, because remember when we discussed end host mode, we know that MAC learning is not performed at all on the uplink ports. So the MAC address of the NAS filer would never be learned, and that would be a problem for connectivity to the NAS. Secondly, if you were to take the NAS and try to attach it to a server port, well, that wouldn't work either, because the server port is expecting to see effects on the other end. It's expecting to see a Cisco UCS chassis, so the link would not come up at all. Now there is one way to sort of make it work, and that was to convert the 6100 to switch mode. And remember, in switch mode, MAC learning is performed on all of the ports, including the uplink ports. So if we attached our NAS to an uplink port in switch mode, we would learn the MAC address and connectivity would be established to the NAS appliance. However, there was a problem with that. Well, at least a couple of problems. The first problem was you had to convert to switch mode to do this, and you had to sacrifice all of the benefits that nhost brought you to begin with, such as simplified connectivity to the LAN, no spanning tree, and optimized MAC learning. All of that you have to sacrifice when you convert to switch mode. Secondly, when you're in switch mode, on the uplinks, all uplinks are forwarding for all VLANs. It's not something that you can prune or filter. It's just any VLANs that are defined in UCS will be forwarding on all uplinks when in switch mode. So if you had a NAS appliance, you're going to want to put that on a VLAN, let's say VLAN 10, and if you attach that to an uplink port, well, yes, you would be on VLAN 10, but that NAS appliance would be exposed to all of the VLANs inside of UCS, and all of the broadcast traffic for all of the VLANs would be forwarded to the NAS appliance, and that's obviously not a good thing. So really wasn't a great way to implement this at all. So there is certainly a way to improve it, and that's what the appliance port, the reason for the appliance port in version 1.4. So in version 1.4, you can now define a port as an appliance port. And the way to think of an appliance port is basically it's a modification of a server port that doesn't expect to see effects or a Cisco UCS chassis connected to it. It will basically allow anything to connect to it. So you can take your third-party NAS appliance and you can connect it to the appliance port, and you can define the VLAN that it belongs to. So let's say VLAN 10, and it will only forward for VLAN 10 on that appliance port. Furthermore, the appliance port learns MAC addresses just like a server port does, so that will allow connectivity to work as well. And in addition to that, the appliance port will also pin itself to an uplink, just like a server port or a server VNIC or VHBA would do. So any traffic that needs to go from the NAS out to the LAN will use a pinned uplink, or any traffic from the LAN that needs to reach that NAS device will come in on that uplink. So again, appliance ports is basically just a modification of server ports that allows a non-Cisco UCS chassis or non-FEX device to attach to it. Performs all the same MAC learning capabilities and uplink pinning that a server port does. And this is designed for, the primary use case here again is to attach appliances such as IP storage in terms of NAS, like an EMC or NetApp filer. Okay, now that we know about appliance ports, how would we actually implement them with a NAS filer, for example, or an iSCSI filer? So let's look at an example here where we've got a NAS appliance, could be a NetApp, could be EMC. Those are the two that are qualified as of right now. And as typical with the NAS appliance, you're going to have redundant controller heads. What we're showing here is C1 and C2. So these are two separate processors on the NAS appliance, and each controller head may have multiple Ethernet interfaces for resiliency and redundancy as well. So we could have a total of 4 interfaces on this NAS appliance, 2 on each controller. And as is typical with a NAS filer, each controller will be primary for any given volume and be a backup for another volume. So we've got volume A and volume B. Volume A is primary on controller 1, backup on controller 2. Volume B is primary on controller 2, backup on controller 1. So what we can do is we can take the controller interfaces, so the 2 ports that are on controller 1, and we can bundle those into a port channel and attach them directly to appliance ports on one of the 6100s, 6100A in this example, and we can make that a port channel. And then we can do the same thing for controller 2. We can take those 2 interfaces, make it a port channel, land it on 2 appliance ports, configure those as port channel on 6100B. So this provides us with redundant connectivity with 2 different volumes defined on the NAS. And now we've got servers below. We've got our UCS servers, server 1 and server 2, each with a pair of VNICs. And these VNICs would be used for NAS or NFS traffic. So server 1 is going to be accessing volume A and server 2 is going to be accessing volume B. Now one thing to keep in mind here is the traffic flow. So server 1 is going to access volume A, and remember volume A is primary in controller 1 and controller 1 is attached to 6100A. So if the traffic from server 1, NFS traffic, to reach volume A egresses out of VNIC 0, which is logically attached to 6100A, then we'll have a direct path of communication from server 1 to volume A right through 6100A and directly to the NAS appliance. However, there is the possibility where we could have some suboptimal forwarding here. Remember that volume A is really primarily attached to 6100A in this case, and volume B is really primarily attached to 6100B. So server 2 down here, which is accessing volume B, again it has 2 VNICs for NFS traffic, and if it's accessing volume B, what if, due to the configuration of server 2, it was egressing VNIC 0, which is logically attached to 6100A, to access volume B? Well, what you would have there is that traffic would reach 6100A, and now 6100A is looking to reach volume B, but volume B is not directly attached to 6100A. So 6100A is going to say, hey, you know, that's a MAC address that I don't know about, so I'm just going to send it out an uplink. And it goes up to the upstream LAN, and the upstream LAN says, well, I need to get that down to 6100B. It might traverse an interswitch link on the LAN, come down to 6100B, arrive on an uplink port, and then 6100B says, oh, you want to get to volume B. Oh yeah, I know the MAC address of volume B. That's on my appliance ports here, and forwards it directly to the appliance port on controller head 2. So you've got this loop that you had to traverse through the LAN to get back down from Fabric A, back down to Fabric B, and to the appliance ports accessing volume B. So it would still work, but it's certainly suboptimal forwarding, and it was really due to the configuration at server 2 not really being aware of which was the best VNIC to egress the traffic for volume B from. It would have been better in this case if server 2 were to use VNIC 1 to access volume B and go directly up to 6100B. Normally this is not something that you would typically have to think about, but now that you're attaching NAS closer to the server at that first hop access layer switch, 6100, this is something that you might want to pay attention to. And again, as I mentioned with the SAN switching mode, where you could attach fiber channel storage directly to UCS, I think the same case applies here, where the primary use case for this is probably going to be smaller pod-like deployments of UCS with very well contained servers, network, and storage, where you want to attach NAS directly to the Fabric Interconnect in a small, well-defined pod. If you're implementing this in a larger data center, it probably makes more sense to take your NAS filer and attach it to some different area of the upstream LAN that's more centrally located across all of the other UCS systems or other devices to access that NAS filer. So just because you can attach NAS to UCS now doesn't mean you always should. This certainly is a good use case for smaller deployments, may not be the best idea for a larger deployment of NAS in a larger data center with UCS. Here's another example of how to attach NAS to the 6100 that's just slightly different from the scenario that we looked at before. And really the only difference here is, remember before in the previous slide we were taking the two interfaces on the controller head and we were connecting it to one Fabric Interconnect and making that a port channel. What we're doing differently here in this scenario is we're taking the two interfaces on a controller head and we're creating them in an active standby pair where one link goes to one Fabric Interconnect, the other link goes to the other Fabric Interconnect, but only one of those can be primary at any given time. So configuration here is controller head 2 is still primary on 6100B for volume B, and controller head 1 is still primary in 6100A for volume A. We don't have the port channel that was defined here before because each controller head, C1 and C2, has its interfaces split across two different Fabric Interconnects. We cannot create port channels of interfaces that are split across the Fabric Interconnect. There is no multi-chassis Ether channel or VPC capability that the 6100A and B is going to provide to other devices such as NAS filers. So it's very much an active standby situation. And again, like we looked at before, we still have to keep in mind the traffic flows. So server 1 accessing volume A, it would be best to use VNIC 0, which is logically attached to 6100A and directly connected to volume A on the NAS appliance. Server 2, if it was accessing volume B, or let's say, I'm sorry, volume A, if it were to use VNIC 1, which is logically connected to volume, or logically connected to 6100B, and was trying to access volume A, well, it's not directly connected to volume A. So it's going to say, well, I don't know where that MAC address is. I'm just going to forward out an uplink, goes to the upstream LAN, possibly traverses an interswitch link. The LAN forwards it back down to Fabric A on the 6100, arrives on the uplink. 6100A says, oh yeah, I know the MAC address for volume A. Here it is on this appliance port, and is forwarded up. So again, this would still work, but it would be suboptimal forwarding. And you're also exposing any potential problems up here in the upstream LAN, like maybe this interswitch link is flaky. Any kind of problems up here would create problems for this NAS traffic that otherwise would not have been a problem had you correctly defined which VNIC should be forwarding to the closest path to a volume. For example, if server 2 were to use VNIC 0, which was or is logically attached to volume A to access volume A, that would have been a more direct optimal path, and you're not exposed to any upstream LAN failures causing problems with that traffic. And this is another slight alteration from the previous two slides we looked at, where our NAS appliance really only has one controller head with two interfaces, and we have multiple volumes on that NAS appliance. So what we can do is we can take one port on each controller head and we can land it on each Fabric Interconnect A and B and make it active for a volume. So port 1 on controller 1 is active for volume A. We'll put that on Fabric Interconnect A. Port 2 on controller 1 is active for volume B, and we'll put that on Fabric Interconnect B. And then inside of the NAS appliance, we're having redundancy inside there for the volumes. So if one of the ports were to fail in a volume, it would fail over to the other port on the controller head. And the same thing applies here in terms of being mindful of the traffic, in terms of picking the best VNIC from that server to egress to access a volume, and knowing which volumes are really active on which Fabric Interconnect, and being mindful of that when you're doing your server configuration in how you've defined which vNICs will be used for accessing a given NFS service.